So today is a day one of 2 days, obviously. So our essential question is, how do I find the probability of mutually, oh boy, that didn't highlight,
No.
of mutually exclusive and inclusive events? And we'll talk about that.
And as we're teaching this lesson, if you hear drilling in the background, that is because Mr. Ware has a student drilling in the, what do we call that? The workroom?
The back room.
Yeah, and I can't stop him.
Because it's finals today. So.
Yeah, so therefore, we'll try to speak loudly. A simple event is an event that describes a single outcome.
Okay, so simple, single.
A compound event is an event made up of two or more simple events. Think of like science. A compound versus an element. A compound, you put two elements together.
Great.
So now, mutually exclusive events are events that cannot both occur in the same trial of an experiment.
Okay.
Cannot. So for example, rolling a 1 and rolling a 2 on the same roll of a number cube
that could never happen.
is not possible.
No.
That is mutually exclusive. I can't roll a 1 and a 2 at the same time.
Okay.
It's not possible. So then we float down here and we see, oh, great. This is a little formula. When we talk about mutually exclusive events, they have that little U sign.
Mm-hmm.
That U sign means or. This or that. When you have the word or, you will be adding probabilities together. And that is so important to remember. Or means add. So when it's mutually exclusive, you are adding the two probabilities together. And like before, we've been multiplying. Okay, this is different now. We're adding.
Okay.
Next page. And on the next page, we have a great example. Example number 1. A group of students is donating blood during a blood drive. A student has a 9/20 probability of having type O blood.
Ooh, I do.
Ooh, and a 2/5 probability of having type A blood. Explain why the events type O and type A blood are mutually exclusive. Well, what do you think, Miss Boyd?
Well, you can't have both A and O blood at the same time.
Right, so maybe we should write that. You cannot have both O and A at the same time. That is why it's mutually exclusive. So you should be writing this down. And we just had the drill in the background, if you heard that.
I think it's a saw.
Oh, it's a saw.
Yeah, it's a saw.
Okay. That's why I don't teach woodworking. Okay, yeah. I teach math instead.
Oh boy.
Okay.
All right.
Nice job, Miss Boyd. Okay, write that down. If you have to rewind back to it, go for it. Oh, I might have to go back up.
Yeah.
Okay.
Yep.
What is the probability that a student has type O or type A? Circle that word.
Or means plus.
So what's the probability someone has type O blood?
9/20.
So let's write that.
And I'll
Plus.
just put like an O up here, so we
Okay.
know that was the O.
Mm-hmm.
Plus our A, which I think was 2/5.
Should I check?
Let's check. Yeah,
2/5.
Great.
Voila. So there's a couple ways to do this now.
We have to get a common denominator.
Yeah, that's what I would do.
Okay.
So the common denominator is going to be 20.
20.
So we have 9/20 is the
so
first
I gotta
one.
multiply this
Oh.
by 4
Mm-hmm.
over 4.
Mm-hmm.
And we get 8/20.
You got it.
Good.
So we have
So
9/20 plus 8/20 is equal to
17/20.
And that
Remember,
cannot
your
reduce.
denominator when you're adding stays the same, and we just add our top numbers.
Exactly.
Just a quick reminder.
Do you want to circle that?
Yeah.
Okay,
Great.
Example 1, that's pretty straightforward. Example 2, each student cast 1 vote for senior class president. Of the students, 25% voted for Hunt, 20% voted for Klein, and 55% voted for Vila. A student from the senior class is selected at random. Explain why the events voted for Hunt, voted for Klein, voted for Vila are mutually exclusive.
Because you can only vote for one person.
Let's write it.
Why are we stuck? Oh, there we go.
We're back.
That was a time lapse. Woo!
Weird.
Okay. So, in case it stopped for some reason, we said you can only vote for one person.
Mm-hmm. That's why it's mutually exclusive.
Got it.
So now, what is the probability that a student voted for Klein or, there's that word, or
So we're gonna
Viola?
add. So just those two, Klein or Viola.
Klein is 20%.
Okay.
So
Viola's
how do you write
55.
that as a decimal? What do you think, Miss Boyd? A decimal?
Oh,
I
we're
would.
gonna do decimal?
Yeah,
Okay.
what the heck?
Well, 20% is 0.20.
Mhm.
We just take 20, we move the decimal 2 spots.
Right.
And we get 0.20.
And if someone wanted to change it, do a fraction, that'd just be 20 over 100.
Right.
You could do that too. And Viola.
It was 55%.
What does that
right?
say? 50. Oh, Viola, 55%. You got it, Miss Boyd.
So then again, move it 2 spots.
Mhm.
And we got 0.55. Add them together.
Right.
We get 0.75 or 75%.
We got it.
Great.
Pretty easy. Mutually exclusive is pretty straightforward. Now we're switching to
Okay.
inclusive.
Okay.
Inclusive events are events that have one or more outcomes in common.
Got it.
So when you roll a number cube, the outcomes, rolling an even number and rolling a prime number, are not mutually exclusive
No.
because there are 3 even numbers on a cube, 2, 4, and 6.
Mm-hmm.
The number 2 is both, and I was going to finish that,
Shows right
prime
here.
and even.
Right.
It's both.
So it goes
So
in
it's
both.
in both the even set and it's also a prime number.
Got it.
So the events are mutually inclusive.
Got it.
There are 3 ways to roll. Oh, I think it
Yeah,
just
we
did
just
it.
talked
We
about
just
that.
talked. So here though, I want you to
Mhm.
focus on this, everyone. Prime number. Notice there's a number not in there. 1
One.
is not a prime number.
Right.
So 2, 3, and 5. And prime number, basically what that means is it's a number that,
Can't divide anything.
yes,
into it
that's what I was,
evenly.
thank you. You're helping me. I'm at a loss of
It's all
words
right,
today.
it's all right.
Thank you, Miss White. See, I really need her. Yeah, here we go. Inclusive.
Great.
Notice that word, notice that U. Do you see the U
Mhm.
there?
I do.
We're still using the word or, but notice we are adding still, but notice we're doing a subtraction. And the reason we're doing that is we have to subtract off where the occurrence occurs in both sets,
times, yep.
or we're double counting
Right,
the probabilities.
That makes sense.
So that's what we're going to go over right now. Here we go. Find the probability on a number cube. Rolling a 4 or an even number.
And we know that a 4 is an even number.
Right.
that's
So
why we
you know
know
what
this
I
is
like to do on this,
inclusive.
Miss Boyd? I like to do like a side note.
Okay.
Okay. So I like to write, let's just, instead of probabilities right now, anywhere, let's write all of the options for rolling a 4. I mean, there's only one,
Okay,
right? You
right,
get a 4.
just a 4.
So 4. That's in that set.
Right.
But now below that,
Mhm.
what numbers are even?
2, 4, 6.
Which number, let's circle, occurs in both sets?
4.
That's why
boy.
that's fine. That's why it's mutually inclusive.
Right, because it happens both times.
Right.
Got it.
And that's the part we subtract off.
Okay.
So the probability of getting a 4 will be 1
Out of
over
6.
6. Plus, the
Plus
probability of getting an
1,
even
2,
number
3.
will be 3
3
out of 6. We subtract off the probability of the occurrence that's in both, which is the 4 is in both,
Yep.
which is 1 out of
Out of
6.
6.
When we add that together, we get 1 plus 3 is 4, minus 1 is 3. 3 over 6, which reduces to
4,
1/2. That's what you have to do when it's inclusive.
Got it.
Let's go to the next one. Rolling an odd number, or, there's the word or, a number greater than 2. So
Okay.
let's write down all the odd numbers on a cube. 1,
3, 5,
and what are all the numbers greater than 2?
3, 4, 5, 6.
Let's circle or highlight the ones that are in both. 3
That one.
and
that
5. Okay, so now, probability of rolling an odd number is 3 over
1, 2,
6.
3.
Plus the probability of rolling a number greater than
That doesn't
2.
look good. Let me read
Oh,
it out,
okay, she's
sorry.
gonna fix that. That's okay.
Okay.
Number-
Is 1, 2, 3, 4 out of 6.
4 out of 6. Minus, which ones are?
1, 2.
There's 2 in both.
So 2
That's
out of
2 out of
6.
6. So now we add the
So
numerators,
we get 7 minus 2 is 5 out of 6.
and that is the answer.
Great.
Example number 4. A card is drawn from a deck of 52. Find the probability of each. Drawing a king or, there's that word again,
Yep.
drawing a king or a heart. So let's do this right now.
Okay.
What are our options on kings? We can have a king. I'm gonna write. Why don't you write KH, which is King of Hearts?
Can I draw it?
Oh gosh, yes.
Okay, so we
You
got
do
a
it.
heart.
Oh, I love it.
We got a diamond.
Yeah, see, I'm not a good drawer.
Oh boy, I guess I'm not really that good either.
She's great.
We've got a spade.
Mm-hmm.
And we've got a clover.
Yes. Beautiful. So how many kings is that?
That's 4.
Yeah. And then how many hearts?
12. 13.
13. There's 13 hearts,
That's
okay?
right.
All right, so which ones occur in both? How many are going to occur in both? So,
Well, there will be 1 king of hearts.
right.
Okay.
So there's one.
Right.
That's what I'm saying. So
Gotcha.
the one that's going to occur in both will be the king of hearts.
King of hearts in both.
Mm-hmm.
Okay.
That's what we have to subtract off.
Gotcha.
So the probability of getting a king is 4 out of 52. Plus, the probability of getting a heart is 13 out of 52. And let's
we gotta
subtract
the 1.
1 out of 52. And when we add all those together,
17 minus 1 is 16 out of 52. That's both even, so I know it reduces.
to 4 over 13.
Sorry about that bell. The bells are off because it's finals day.
And there we go.
All right.
I'm just going to page forward a minute
Yeah.
just to see what we have left.
That's what
You
I
know,
thought.
I think we
save
should
one for
leave
class.
that.
Yep.
So let's go read
All
through
right.
these. And
Pam rolls a 1 through 6 number cube. Find the probability. Pam rolls an odd number or a number greater than 4. So write down your odd numbers. Write down numbers greater than 4. Which ones are in the same? Subtract it out. Here, Pam rolls the cube again. She rolls a 3 or a 6.
that has to be mutually. Number
Mhm.
1 is going to be mutually inclusive. And number 2 is going to be mutually exclusive because you can't roll a 3 and a 6 at the same
Right.
time.
All right. See you tomorrow.